Good morning, good afternoon, or good evening, wherever you may be in the world. Thank you for joining us today. My name is Joy Bastaros, and I'm going to be your webinar host for the day, coming to you from Houston, Texas. I'd like to welcome you to today's webinar. Our topic for the day is Intelligent Schematics for Piping and Instrumentation Diagram Design. A little bit about today's presenters. We are happy to welcome Mike Oshbaugh with us today. He is a Business Development Manager for Solid Edge Electrical Design. Mike joined Siemens Mainstream Engineering in 2019 to support the Solid Edge portfolio products. He came to Siemens from Mentor Graphics, a Senior Applications Engineer and Process Consultant for Worldwide Distribution Sales Channel. He holds a Bachelor of Science in Electrical Engineering from Penn State University and a Bachelor of Science in Physics from Westchester University. His focus is enabling Siemens customers to address the ever-increasing design complexities of electrical systems in their smart, connected electromechanical products. Happy to have you with us today, Mike. We also have with us Sangamesh Andor. He's a Senior Application Engineer for Global Technical Enablement for Mainstream Engineering, and he joined Siemens India in 2011 as a pre-sales technical consultant. He moved to Siemens Global Technical Enablement Team in 2019 as well to support the Solid Edge portfolio products, focusing on modular, plant design, and team center integrations. He holds a bachelor's degree in Industrial and Production Engineering from Karnataka University, Dharwad. His focus is enabling Siemens customers to address the ever-increasing design complexities in data management and plant process industry with our smartly integrated Solid Edge portfolio products. Happy to have you with us as well, Sangamesh. And with that, I'll turn it over to Mike to kick us off and get us started first.
Yes, and Joy, thank you for that kind introduction, and welcome everyone to this session on Intelligent Schematics for Piping and Instrumentation Diagrams. We're going to do an introduction of the Solid Edge modular plant design. So I'm going to discuss with you the industry trends and challenges with plant design, and then describe how Siemens has expanded the Solid Edge portfolio to help those companies meet those challenges. So I'll present today for about 15 minutes, and then we'll invite Sangamesh to deliver the software solutions that he'll be showing today. His demonstration will be about 25 minutes, and then I'll come back and do a short wrap-up, and we'll answer a couple of questions. So let's get started. Modular plant design. What is it? What do we mean by modular plant design? Modular plant design is a market trend of designing process plants in small modules. These modules are built at the shop, and then they're delivered to the site for installation and integration into the system. So we're subdividing these systems into smaller parts. Now, we also refer to that as modularity. So why is that important? Well, this is the approach that resolves the business pressures to deliver those more highly customizable products within a shortened cycle time. And the demand and challenges are stemming from manufacturing processes that are getting more refined. This requires more equipment or equipment that needs to be changed in the plant to support these new refined processes. This is also making the projects becoming much larger. They're increasing in complexity, and they do require more engineering work. One of the big factors for increased complexity is more regulations and new regulations. You know, regulations vary from region to region, from state to state, and they vary between the countries. But all the regulations must be followed. So we need to be in compliance. So if we sum this up, the businesses have increased complexity, requiring more engineering resources, but they have less time to deliver these plant designs. So the traditional approach of building everything on site has just really become too risky. It's too costly. And businesses are unable to meet that shortened cycle. So how does modularity help with this? Well, by subdividing the systems into small modules, the modules can then be swapped out within this larger system to deliver those customized functions and capabilities. The modules are designed with unique capabilities and functions with several variations to them. By combining these modules in the appropriate configuration, that creates the custom equipment needed for these plant design requirements. And from an engineering resource perspective, modularity increases the variability and it increases the reuse. So this is really excellent news for the engineers. More reuse and less customization. But there's also other benefits of modularity. We get quicker turnaround for these requests for quotes. There's better control of the construction conditions, and that certainly helps us with controlling cost and reducing the errors. Here's a link to a nice article entitled Modularization, the Key to Success in Today's Market. And the article goes on and describes some of the concepts we're just presenting here. Modularization accelerates the schedule, minimizes risk, and it improves the quality and control of the construction cost. So we may think initially process and plant design, mainly for the oil and gas industries, but there really are others that are a very good fit too. And here's a list of some of them, which includes water treatment plants, equipment and container plants, hydraulics. Really any project that has piping and tubing is a good fit. And there's certainly a lot of tubing in the food and beverage industries. The modules that get built in the shop and packaged for shipment to site would look something like this. Here's some examples. Here we have a skid, a container, and a crash frame. So we get those ready to ship, and they would be delivered to sites that look similar to what you're seeing now on the screen. And once they're delivered, they would be installed and integrated into this larger system. So this is the new methodology, the trend, to replace that traditional approach. And by doing this, businesses are better positioned to deliver those highly customizable products given those shrinking schedules. Let's look at the workflow of the modular plant design, and we'll describe it in 3 steps. There's the planning, communicating, and manufacturing. So in the first step, we capture the design content in a schematic using P&ID. P&ID is an acronym for Piping and Instrumentation Diagrams, or Process and Instrumentation Diagrams. The terms are really used interchangeably. In step 2, the information is communicated to the 3D environment, making sure everything works and it's got to fit properly. And the third step is the isometric output. And here's where the fabrication piping drawings are created for the shop to manufacture them. The Siemens offering of solid edge modular plant design, it consists of 2 products, solid edge P&ID and solid edge piping design. And this has been integrated for the solid edge. And we're going to take a deep dive into both of these. And the first thing I want to mention is the technology in solid edge P&ID. It's from SMAP 3D, and SMAP 3D has sold over 1,800 licenses worldwide and used extensively in the industry. So my message with this to you is this is mature software technology, and it has been added to the solid edge portfolio. The solid edge is not just an MCAD system, but really a portfolio of a number of products. And in the past few years, over 50 new products have been introduced. And we organized the portfolio into 7 pillars, which are shown here. On the mechanical, on the far left, is where we have placed the P&ID and the piping design technology, adding it to the mechanical pillar. So let's look at the data flow when we talk about modular plant design. This will give us a good understanding of where the data gets entered and how is it shared in this process. This slide shows us the two modules, P&ID and piping design, and the interface between them. The intelligent data from P&ID is communicated directly to piping design using the data exchange link. There's no need to enter the same data or re-enter it. In piping design, a to-do list, it organizes the instructions and tasks so nothing gets overlooked or missed. And the cross-highlighting in the interface, that enables the design efficiencies as components are placed and the pipelines are routed in the 3D environment. At the top, we're showing the libraries and that they're linked to the applications. And they're tied together in the same database for automation and easy access to any of the information, when you need it and where you need it. The pipe specification is a common link between P&ID and piping design. In the P&ID application, the pipe specification filters the valid component selection based upon the pipe sizes. When piping design reads a schematic, it's the pipe specification that automatically adds all the fittings and then creates the piping assemblies. Keep in mind, both P&ID and piping design, they can be run standalone, but if data is exchanged, you'll get the experience of that full 3D digital twin environment. So let's look a little bit deeper into each of those products. First, the P&ID. It's a 2D intelligent schematic, and it details how things logically get connected together. It describes the process workflow, capturing the connectivity of the modules and the individual components. Now, we say intelligent to describe the schematics because it's working off a component database. And because of this, information for the pipelines and symbols, they're easy to find and access, which saves time and it reduces errors for the user. The user can search or query the component database to find the right pipe specs for the appropriate industry standards. And in real time, there's a design rule checker that enables automation and the verification. We want to make sure that the content in the schematic is correct as it's captured, and it catches the errors immediately for us. Intelligent schematics means that any generated output document is accurate and complete, and it's always consistent with the diagrams. Two of the important outputs generated included the bill of material and an intelligent PDF. The PDF is really helpful to share with your colleagues and team or for field maintenance documentation. Using any PDF reader, all the properties of the components and the pipeline can be viewed because they're attached within the intelligent PDF. Sangamish will show these features in his demonstration because he's going to highlight for you the value of using an intelligent schematic product. Next, we have the piping design. This allows us to see in 3D layout just how things will look when we go and build them. Piping design reads the intelligent data from P&ID using that data exchange link, and then the components are placed and the pipelines are routed. To route the piping, you simply draw the path from point A to point B. We provide the spec and sizes of the pipes, and then the automation of the software takes care of the rest for us. And this automation includes the fittings, whether it be welded, threaded, flanged, stainless, or PVC. There's additional functions automatically that get created, such as installation, reducers, welding gaps and tees. All these small little things like nuts and bolts, they are very important details. HVAC ducting and cable trays are also supported, so the shapes are not limited to just round pipes. Also, with solid edge piping design, it automatically creates the isometric drawings that transfers the attributes from the 3D pipeline. These are the single line drawings that are used by the shop for the fabrication. Modular plant design also includes extensive out-of-the-box industries, and they support the industry standards to help capture the best practices for plant and equipment design. These libraries include 2D P&ID symbol libraries. They include 3D piping libraries. Here's where you have the gaskets, the elbows, T's, and those 3D parts from the real world. And roughly now there's over 130,000 components provided. And we have the ability to add customer-specific libraries, and there's a library wizard included to help facilitate this. And since we're creating and using native solid edge parts and assemblies, we can still use all the solid edge draft functionalities. In Sangamesh, when he starts his demonstration, he's going to show you both P&ID and piping design. And he's going to highlight the automation and the intelligence of this workflow. Some of the key highlights you'll see is the anatomy of what makes up a project and the graphical user interface. He'll show you making queries into this component database that's provided. The effects of design rule checking to make sure you have nice and clean schematics. And then working from the to-do list instructions, so we're cross-highlighting with 3D. And so with that, Sangamesh, I'll invite you to share your desktop, and we'll see your demonstration.
Hello everyone, a very good morning and good evening. I will take next 25 to 30 minutes to give a brief overview of our modular plant design product, focusing on P&ID, piping, and isometric drawing creations. Solid Edge P&ID is a project-based system for a schematic capture tool, primarily focused on process and instrumentation diagrams containing many different types of documents in one digital file. It's an intelligent P&ID system. You will see through the demonstration why I say that and why it is important. Let me first show you how this tool helps in creating P&ID projects, the information which can be captured in the project, finding the information about symbols and pipelines, symbol libraries, and customizable toolbars. So let me start here by showing the demonstration wherein you can start creating the project by using the out-of-the-box project templates, or you can also customize these templates according to your industry standards. So as I create this project, I can provide some project title as a property, similarly some value which is like a kind of a project number, project name, as well as property value against customer. Even these fields also can be customized according to your requirements. As I continue and create the project, it basically adds different documents which are part of my projects, like cover sheet, the diagram sheets, the list, like the bill of materials, component list, data sheets. All these sheets can be collapsed or expanded, similar like Microsoft Excel application. As this project I newly created, let me move on and open an existing project which has some information using which I can show the other capabilities. Heart and soul of the projects are the diagram sheets, wherein normally you define all the pipelines by placing the components and equipments, where in this solution you can quickly find the information related to a pipeline by highlighting on a pipeline, which basically shows you the information like the pipe size, the article number, the spec which it belongs to. Similarly, if I highlight on a symbol, it shows the description. In this case, it's a double tube heat exchanger with the article number as well as the type of the equipment. As in this project, I have only two diagram sheets, but in your case, it may run into multiple pages where you would also like to define the pipeline connection in different sheets. For that, we have a solution like wherein you can define those connection points as a line links which automatically captures the corresponding information where exactly that pipe is continuing on the other sheets, like the sheet number as well as the zone in which it is going to continue. The other nice thing about these links are you can click on them, it automatically navigates to the corresponding uh, page and exactly locks your cursor where that particular line is going to continue on that page. So you have the symbol library. Out of the box, we provide many international standards like ISO 10628, 62424. Similarly, ISA 5.1 and 5.5, which are more commonly used in North America, and many of the pneumatic symbols are also provided out of the box. Including this, we also provide different drawing templates using which you can customize according to your standards. So the next thing is creation of the custom symbol, where also we provide multiple options to create the custom symbol. Like you can create it from scratch, or you can use the wizard kind of thing, which is a quicker way of uh, creation or creating the custom symbols. So other than this, we also have the options wherein you'd like to import the symbols in different formats and you want to convert into a native symbol. So that can also be done using our solution. So it's always a time consuming activity where user would like to go through these symbols and find the uh, corresponding symbol before he starts creating the pipeline connections. So that's the reason we also provided the pick menus which are customizable wherein you can add the frequently used symbols under this customized toolbar, or you can also add the symbols which are you are going to use on a particular project. So it's easy way of adding those symbols so that those will be available across the sessions of when you are working on a project. So you can quickly create the project. It's easier to find and navigate between the objects, which helps in faster decision makings. Create custom symbols and project templates based on your industry standards and adhere to it. It's a fully customizable solution which helps in faster and precise creation of the piping schematics. The next thing I would like to show you is the pipeline creation. Uh, how our solution helps in creating the P&ID diagrams with the different use cases. We know the industry requirements where we support and also know the process which may not be unique when it comes to different industries. Here, I will show the pipeline creation on the diagram sheet with the different use cases. The first use case is where like most of you when you are early in the project, like in a conceptual stage where you don't have the component information and you would like to start creating the project. So for that, we have the symbol menus wherein we can browse and start creating the pipeline connections to those place symbols, or you can also use the the pick menus, the symbols from the pick menus, wherein you can quickly place the the symbols at the right location on the project before you start defining the pipeline connections. So when you start creating the start placing the symbols, you also would like to add a unique number to each object, as there are multiple objects like components or the inline components or the pipelines. So most of you would like to provide a unique number to differentiate that. So out of the box, we have a solution wherein which provides already the used names across your projects, so that you can continue and provide some unique name to the pump which I have just placed. So let's place a uh, unique name to that pump. So again, you have the option to cross-validate quickly and see whether that particular information or the tag number has been used. In case it is used, you would like to also jump up by the next available number. So we have the solution which quickly updates to the next available number, and you can continue and add this information onto your project. So as I defined by placing a pump symbol, the next thing we would like to do is define a pipeline connection from one of the component, in this case from the heat exchanger to one end of the pump. So as you create the pipeline connections, it basically creates a dynamic link wherein as you move the symbol, the pipeline remains associative, even in case there are some intersections, it is going to update accordingly. So this is a use case wherein in the concept stage you can start placing the symbol, and later you can assign the components to that symbol. So the other case which I was planning to show you is you already have the component information, and you would like to define the pipeline connection by placing those components. In that case, you have the component database where you have many options to search for a particular component based on type or based on say description, or you can also search by article numbers, and you also have multiple options where you can search based on the properties associated to symbols. I can search for a uh, part which is supplied by a particular manufacturer. So like for example Apex, or I want to search based on the current force supplier. So it basically lists down all the components which are supplied by that particular uh, manufacturer. So in this case, I'm going to show by placing this pump and define a pipeline connection by defining its also the size, as well as place a wall on the pipeline. So as I place this pump onto this project, you can also quickly define the scale according to your need and orient it and provide a unique number again. And again, you can also cross validate whether that particular number has been used or not. As the pump is the first thing which normally you would like to place before you start creating the pipeline connections, you can define it as a outer equipment, and you also have the option to provide different property values, which you call it as data fields, like say operating temperature, design temperature, similarly maximum temperature and pressure as 15 bar, and design pressure as 18 bars. So I'm going to I have basically defined some of the properties which you can also view it once you place that symbol. So as you highlight, you can see all those information as a preview. So let me add a pipeline connection. Again, similar to the use case one, like I'm going to create a pipeline connection. However, in this case, I know which is the size which I need to define on this pipe. So I can pull in from the library and assign that corresponding pipe. So before you pull the library part, you would also like to provide this pipeline with a unique line number, wherein user also gets kind of a cheat sheet, like we have where you will get different codes to represent different kinds of fluid medium, which also can be customized according to your requirement. So let me start with providing a unique number to this line number, and also provide the diameter by pulling a particular pipe from my library using pipe specification, and also define the medium as a hot water. In the case like if I want to reuse this information on another pipelines, I have the option to select and copy all the properties of this line, so that that information can be reused. And I had also option to quickly orient the tag name to the other side of the line segment. Now let me show how we can add a in-place component on this particular pipeline by pulling it from the library, where it automatically filters me the size which is matching to the diameter of the pipe which I have selected. So it's very helpful for the designer, as it filters it automatically and provides only the matching components from the database. In this case, I am going to pull a wall from the component database and place it at one end of the pipe by providing some unique name to that. So as I place, it automatically orients to the pipeline on which I have placed. So let's continue and create another pipeline from the other end of the pump to the vessel here, and edit the line, and use the copied information from the other pipeline, and we can also paste that same information, as I'm going to define a 100 diameter size for the other side. And you have the option to quickly up the line number by one. Is it easy to again uh, place a unique name to each objects on your piping schematics. Let me continue and place this information. So as I had defined the create the pipelines by placing the components and defining a particular size for the pipe. Next thing you'd like to do is the whether your schematic is in accordance with your standards. You want to validate your design against design rule checks. Before that, I would like to also mention, like some of you maintain the component list outside of the P&ID application, like in an ERP system or in an Excel file. So we have the option to import the connection list inside your project, and place that information and reuse that component information to continue on the project. Similarly, some customers we have seen, like they would like to modify the properties of all the components outside. For that also we have a solution wherein the solution exports all the component information with the data fields, that's the properties, and you can edit it outside and import back into the project and update the corresponding properties associated to each component. So to summarize, you can quickly create the piping schematics based on your company and the standards. It also supports multiple use cases and helps in avoiding duplicate tag names. With a quick search of the components and reuse them in the project, it's easier and faster creation of the piping connections with better data reuse. Finally, it also helps in reducing costly errors with the capabilities of unique tag numbering. So as I said earlier, we created some of the new pipelines, the next step would be um, to make a validation. So let's see how our solution helps in validating the design. So out of the box, we have different design, multiple design rule checks related to symbols, connections, uh, as well as lines and wires. Let me show one of the important check, which is of a compared diameter, where it basically compares the diameter of the pipe with the components which are placed on that pipeline. So let me continue and validate my design against this particular check. So there is a warning which has been shown. As I highlight on that warning, my cursor automatically moves and locks to the exact location where that particular information is displayed. So I can edit that information and see that information which is uh, of the pump, which has one end of the pump has the diameter of 80, whereas I had defined the line size of 100. So let us fix this issue quickly before you continue and show how we can generate the reports out of your P&ID schematics. To fix this issue, let me uh, reducer in between the pipeline by specifying a unique number to that. Also define the connections as it is a symbol, and then I can edit the pipeline and modify it to suit the other end of the reducer. So let me make it as 80 and continue with the project. And again, I can do the revalidation, and now you can see there is no warnings, no errors. So it's safe to continue and create different kinds of report. So to summarize, we can cut down the errors and compliance issues using the out-of-the-box design validation tools, thereby improving the quality. Next, I would like to show the report that generation, which is very important for any industry, as this is the information which will be referred by other departments like purchase or electrical department, fabrication and final assembly, and even suppliers too. So you can generate the reports which are internal to the project, and also you can generate the reports which are external and which can be shared to the outside world. So let me show you a couple of reports which you can generate. Some of the reports I already generated, like the part list, which is associated to the your P&ID diagram sheets. As there is a modification on your project, I can quickly come back and update these sheets. Similarly, the component sheets, which these are also associative. All the reports which are internal are associative to your diagram sheets, the project, and wherein you can, as there is a change in the schematic, you can come back and update these component list as well as the part list. So the other good thing is you can quickly navigate between your component list to the P&ID diagram sheet. As I placed a new pump on my P&ID project here, when I click on that particular line entry, it automatically takes my cursor to the exact location where that pump has been placed on a diagram sheet. So for a process engineer, it's very easier to find the required information uh, anywhere which might be existing anywhere across your project. Similarly, you can also generate the equipment data sheets, where in this case I'm going to show an example where I'm going to add a data sheet specific to the vessels. In this project, I have used a couple of vessels So I want to place that information in individual sheets. So I can update the list. Basically, uh, it creates the data sheets and pulls in the values from those components and places and updates vessel data sheet. Similarly, you can customize and create data sheets for any of the equipment. All these templates which are shown can be customized according to your industry standards. So not only this, like some of the other departments, when they want to go through the project, they would like to see more information. It's not only like the article number or the unique name to assign to that particular symbol. They also would like to see the product specs of that particular component, so they can quickly validate view those information by using the out-of-the-box solution. So, though, let us see some of the external reports in which all formats we can generate the reports which can be shared to the outside world, wherein similar to the internal part list, we have the option to generate the part list. That's a bill of materials with the different formats like comma separated file or an XML file or a Excel file. You can also specify the properties which needs to be uh, included in the part list which you are going to generate. Similar options are available also for component list generation, which gets exported in a different formats, and connection list file also, like some of the customers also like the pipeline information to be shared to the downstream manufacturing and fabrication, wherein they can generate the connection list file where the focus of this output is on the pipeline, from which component to which component that particular pipeline has been defined, what is the corresponding pipe size and to which spec which it belongs to. So not only this, you also have many other export options like TWG, TXF, but I would like to show one thing that's a PDF creation, as Mike in his overview has mentioned about the intelligent PDFs. Let me show how this information gets generated, wherein I have the option to select a particular information which needs to be exported, like the diagram sheets or the BOM sheet or the component list, or I can tell the system to capture all the information, and also I can tell the system to include or exclude some of the properties which should be carried and while creating the output. So this is very important for you. Like many of you want to protect your IP, some of the information related to costing, other things you want to hide it before you want to generate the output. And let me select all the properties which needs to be included when it generates a PDF, and create a PDF drawing by specifying a name to that. So as it creates a PDF, it's a similar like your project file, which contains the information of a cover sheet, index sheet, similar information as you view on the P&ID project file, like the diagram sheets, wherein also I can highlight on a pump. It also shows you all the information similar like how you view it on a project file inside the application. Even when I highlight on a pipeline, it shows the corresponding parameters associated to that pipeline. Similar behavior you will see in the BOM list as well as the component list which it has generated, wherein you also can quickly navigate from your uh, component list or part list to the corresponding component on the diagram sheets. So you can call it as intelligent PDF, which has all the information related to the project. So to summarize, you can quickly generate the reports inside or outside of the project and can be shared to the other departments or suppliers. All these internal reports are associated to your project and can be updated when required. All these templates can be customizable, and you can also filter the list to find the related information. So as you have finished by creating new pipelines, by placing between the components and some inline components like wall, next thing we would like to see is like how this information can be or whether this information can be used in the 3D piping creation. So the nice thing about our solution is like this information in the back end can be connected to our piping application, which basically reads all this information. As I have modified my P&ID project by adding the new information, I can come back here and update it so that it reads all the new information and shows you the uh, changes which have happened into your 3D CAD application, that is solid edge piping application. So you can see the information like some of the components are represented with a different color. That means those are the new components which are added into my schematic. So that's the reason it is showing the different color representation with the blue sphere. That means those are the outer components like pumps which were added first before you created a pipeline connection. So that is the first thing you would also like to add into your 3D assembly before you start creating the pipeline. So as I uh, uh, use the option to add it, it automatically pulls the corresponding 3D component from the library, and it allows me to place at the required location onto my 3D assembly. So as I added the component, it automatically changes the color, and you also have the option to cross highlight between the P&ID application and also the solid edge application here. So as I'm highlighting on the components, it automatically highlights in the 3D display, as well as it gets also highlighted in the P&ID application. So very helpful for the piping designers who wants to cross check or validate whether they are creating the piping assembly in accordance with the schematics which has been defined. So before you start creating the pipelines, you also can preview the information like how those components needs to be connected in the 3D uh, 3D application. For that, we have the solution where it automatically shows with the representation, different color representation, how that particular pipeline has to be connected between which component. So I can use this information and continue and create a pipeline to to convert into a 3D assembly. So you have the different options to different to address different use cases. In this case, I'm going to use a quick way of creation with one of the option which is provided out of the box, where I can define the start and end. It automatically selects the other thing, and I can provide the distance along which it should be stayed. The pipe should be stayed before it starts bending, and I can pick the other end of the component as it showed the preview. So uh, so let me recreate this line here. by deleting that line, as I have selected a wrong alternative which has been shown. So let me again recreate that line and just correct it from one end to the other end. So this is the one end where I'm going to provide the distance along which it should be stayed before it's start bending, and that's the other point. So as as you created, system also provides you the option, different alternative ways in which that pipeline can be represented. I'm going to select one of that and finish up my sketch for the 3D for the 3D pipeline. So as I come out of the pipeline creation, it automatically picks up the corresponding diameters and all the fittings which are specified in the specification, and it automatically creates a 3D piping. So at one of the end, I also defined a wall. So let me quickly delete this flange here and place a wall by pulling it from the library. Similar to the pump, I can pull this information from the library and it automatically picks up corresponding 3D component and provides me the option wherein I can specify how that wall has to be positioned. And as I finish up this operation, I can quickly update the piping so that the pipe also gets trimmed to accommodate that wall, and it also adds the flanges automatically on the other side of the wall here. So as we completed the 3D assembly creation using the information from the P&ID application, let me open it individually and show you how we can create the single line drawings. It's isometric drawings wherein we have the integrated isometric application. This also works as a standalone. As the assembly is opened in the back end, uh, it basically reads that 3D assembly which has been created, and it also provides me different style formats in which the output has to be created. So I'm going to pick a couple of these and tell the system to create an isometric drawing for the 3D assembly which we have created few minutes back. So as I continue, it basically in the back end, it reads all those information and creates the output in DXF DWG. Also, it converts those files into native files. That's a solid start file, which I can open it and see the information related to the piping, 3D piping, which we have created, wherein all the uh, components, including the fittings, has been defined. Also, the weld points and the pipelines and the tables, which is most important. That's the fabrication as well as the erection and cutting list information can be added as a part of this output. So these output, the templates can also be customized according to your need. So when you create the isometric drawing, it basically generates the output in the templates which you have customized. So that was a quick overview on our solution wherein we can use our P&ID application to quickly create the piping creations for the piping creation by using the out-of-the-box library or from the component database, and validate your design. And you can also use the information of schematic to quickly create the 3D pipings and finally the corresponding isometric drawings for the 3D pipings which you have created. So that was a quick overview from my side. Over to you, Mike.
Okay. Thank you, Sangamesh, for that demonstration of the modular plant design. There's a real nice overview of the 3 steps in that workflow. And you showed us the easy creation of intelligent diagrams and pointed out there's a lot of opportunity in there for customization in many ways. You know, and the power of the design rule checking to help validate those schematics, really very powerful, and then the outputs that you showed us. So thank you for that. You could see a lot of key features in there, right? Help provide that true 3D digital twin environment. So as we come to the close of our presentation, right, I would encourage any of you interested to reach out to your Siemens representative. So if you'd like to evaluate solid edge modular plant design, they can certainly help you with that. Or maybe you need a deeper conversation and a discovery call with your team. They can certainly help with that as well. Or perhaps a more detailed demonstration. So think about what you need as your next step, because they're happy to help you. For those of you that may be new to Solid Edge, we welcome you to try that for 30 days. Here's a link on this slide where you can get a free trial to do that if you wish. And then finally, I want to thank you personally for your time. I know your time is valuable, and I was happy to be a part of the presentation today.
And with that, this officially concludes today's webinar. I thank you all so much for joining us, and have a great rest of your day or evening.